Welcome to today's session from the Gudsky Research Foundation's Applied AI and Machine Learning Educational Series. Gudsky Research Foundation is a knowledge-driven initiative committed to bringing high-quality education in artificial intelligence and machine learning. It's completely free of cost to learners worldwide. The idea is simple. AI and ML are shaping the future, right? And we believe that every learner, regardless of background, deserves access to this knowledge. This is a 6-month structured program where we cover AI and ML step by step. Each session combines theory, examples, coding, demonstrations, and real world case studies. By the end, learners will not only understand the concepts but also be able to apply them in projects, internships, and even research papers. Today we are going to dive deep into one of the most fundamental yet looked stages of machine learning, that is data preprocessing. So what is actually the data preprocessing? So whenever we talk about AI, people often think about advanced algorithms like neural networks, deep learning or transformers. But the truth is the real power of AI doesn't just come from algorithms. It comes from the data. Okay, now think of this way. A chef is only as good as the ingredients available. Even the world's best chef can't make a delicious dish without spoiled or rotten ingredients, right? Similarly, a machine learning model can't perform well with messy, inconsistent or incomplete data. Okay, that's why we need a data pre-processing pipeline. It means a structured set of steps to take raw data and clean it and organizing it and transform it into something a model can actually learn from this. This includes data cleaning, data transformation, data integration and data reduction. Okay, now uh, let me give a quick examples for this, like data cleaning means fix missing or wrong values. That means we'll fix that values, like if the value is missing, we'll insert the correct value. Like data transformation means scaling, normalizing and encode the data. Okay, and data integration means combining the multiple sources and resolving the issues from the data. Data reduction means removing the unnecessary features which are not it's unnecessary, so it is not useful. Okay, this is what data reduction. Okay, now we'll move to why pre-processing is essential. Okay, let's define this clearly. Data pre-processing is the process of cleaning, transforming and organizing raw data so that machine learning algorithms can learn patterns efficiently. So why this necessary? Because real world data is messy. Okay, everybody knows this. Like we can't insert all the real world data into a table like a perfect data, right? So it is a messy. Imagine working with bank transactions, medical records, e-commercial sales, some having missing account numbers, some patients blood pressure is missing, some having typing errors. So in e-commerce sales, some prices are in dollars, others in rupees. Okay, if we give this directly to an machine learning model, it will fail. But pre-processing ensures data is consistent and accurate. Think of building a house. Before construction, the land must be leveled, cleaned and prepared. Similarly, pre-processing is the groundwork of machine learning. Without it, the entire model may collapse. Okay? So okay, let me ask you. If you give a student the wrong notes to study, will they pass the exam? Probably not, right? Similarly, ML models can only be good as the data they are trained on. Okay? Without pre-processing, problems arise like garbage in, garbage out. It means wrong data leads to wrong predictions and inconsistent data. Inconsistent data means different formats confuse models. Okay, if we give one format, then it will do it work correctly. If we give different formats, then how it will work correctly? So it's completely confused, okay, and training becomes slower means noisy data like incorrect data makes models spend more time searching for patterns, and accuracy drops. Models fail to generalize to new situations, okay. Now we'll see an example. If you don't understand this, we'll I'll give a quick example. Predicting house prices. Like if half the dataset has missing square footage and the half is in the different units like square feet, square meter, the model simply won't learn properly, right? And if you don't understand this also, I'll give one more example. In healthcare, imagine missing values for critical attributes like oxygen levels. The model might make a wrong diagnosis, which in real life could be fatal. So, pre-processing isn't just about numbers. In sensitive domains like finance, healthcare, or self-driving cars, pre-processing can literally save lives. Okay, this is what the pre-processing. And we'll move to learning objectives. By the end of this lecture, you will be able to clean data, transform and scale, feature engineer. Okay, cleaning raw data means identify and fixing the incorrect values and remove the duplicate values and ensures consistency means accuracy of data. Finally, after cleaning the data, it will be accurate, and transform and scale, which means converting categorical values into numeric form. Okay, normalize or standardize data so that different ranges don't bias the model. Okay, feature engineer means creating new variables that give models better insights, and also it's turning date of birth into age. Okay, in short, you learn how to take a messy real world dataset and prepare it step by step until it's machine learning ready. Okay, this process directly improves accuracy, reliability and fairness of models. I hope you understand the learning objectives. Now let's move to next slide. So real world data is messy. Yeah, of course it's messy because missing values, noise and errors, duplicate, inconsistent formats, unbalanced data, irrelevant features. Now we will see this one by one. Missing values means imagine a survey where 20% of people skip the income question. If we ignore this, our analysis is biased. So it may get the wrong values. Okay. Noise and errors means in sensor data, suddenly spikes might occur because of hardware faults. So this is the noise errors. And duplicate means in e-commerce one customer order may be logged twice, inflating sales. So for the same customer data entered by two times, so this may be the duplicates. Okay, inconsistent format means one branch logs, that means 01/02/2024, that means 1 of February 2024 as Feb 1st, another as Jan 2nd. How this can be in a right format? See, there are different formats, so we can't understand. So it is an inconsistent format. Unbalanced data means in fraud detection 99% transactions are normal, only 1% fraud. Models may predict everything as normal. So irrelevant features means extra. If you are predicting diabetes, the patient's favorite movie genre is irrelevant. So if you are predicting a patient diabetes, like the patient is in diabetes, what you will do with the patient genre of movie? So it's the irrelevant feature. A great way to remember raw data equal to like a messy kitchen. Okay, understand like this and it will be really helpful to you. And pre-processing means cleaning and arranging and preparing ingredients before cooking. So this is what pre-processing. Raw data means like a messy kitchen. Okay, now we'll move for. Okay, here we see the Titanic dataset snapshot. Here we are seeing some errors like missing the values of age, and embark like means female or male, and deck means the value of a person. So here missing values are represented in a bar chart. Understand this. The missing values means inconsistent of data, okay, and the error. Now impact of poor data on machine learning models means poor data directly affects performance, like quality issues, overfitting, underfitting, wrong predictions, bias and fairness issues. Missing values or noisy entries mislead the models. Okay, overfitting means the model memorizes noise instead of patterns. That means useful things are leaved and unnecessary things are memorized. This is called overfitting. Underfitting means the models learn too little because the data doesn't provide enough signal. Okay, wrong predictions means lead to false conclusions in business and healthcare. Bias and fairness issues means, example, if a credit approval data set mostly have male applicants, the model may wrongly learn that men are more credit worthy. In the real world, these issues can cause financial losses, unfit decisions, or even safety risk in critical systems like self-driving cars. Okay, now we'll move to the next slide. Key processing stages. The processing pipeline can be broken into three main stages, which is data cleaning, data transformation, and feature engineering. Data cleaning means handling the missing values and making them correct, removing the duplicate values. That means making the multiple values into single values, that means correctly. Fixing errors means if any errors are occurred, that will be corrected. Data transformation means encoding the categories and scale numeric features. And feature engineering means creating new variables like family size from siblings and parents data. Okay, this is what key processing stages. If we move for case study in Titanic survival prediction, in cleaning we'll first step we'll do cleaning, right? In cleaning we'll fill the missing age with median. Transformation means encoding gender into 0 and 1. Okay. Feature engineering means add a new column family size equal to SIB SP plus patch. These steps increase accuracy dramatically. Okay. Now we'll move to next slide. What is data cleaning? So data cleaning is the foundation of preprocessing. It ensures that data set is accurate, complete and trustworthy. So it is the process of identifying, correcting or removing errors, inconsistencies and inaccuracies in data. As we previously discussed about it, it means data cleaning means correcting the misinformation. That's what the data cleaning. Okay. The main purpose is improves the accuracy and reliability of machine learning models, ensure the model learns from high quality trustworthy data. It means it will handle the missing values either by removing or filling them. Removing duplicate means so no information is double counted. Correcting error means fixing type and mislabeled entries. Handling outlier means extreme values that may skew results. Okay, this is the key steps and purpose of the data cleaning. And if we take an example, if an airline dataset says a passenger age is 400, that's an error, right? Nobody can live that many years. Cleaning would either fix or remove such cases. Okay, remember a clean dataset is like a sharp knife or a chef. Okay, a clean dataset is like a sharp knife for a chef. Without it, the best cooking skills won't matter, right? This is what the data cleaning. Now we'll move to the next slide. Techniques for handling missing data. Before that, we'll see handling missing data. Missing data occurs when certain values in a dataset are absent or not recorded. Okay. Now common causes for this missing data is, as many of them are doing a data entry, some human typing mistake, like by typing they didn't enter the data, issues during data collection or sensor failures, and system or software errors. Okay, and handling technique means remove missing data or drop rows or columns with missing values. Impute missing values, replace with mean, median, mode or predicting values. Use algorithms like handle missing data. Some models ML can work with missing values. So this will next discuss about this handling techniques. So these are the common causes that are occurred for the handling for missing data. So proper handling of missing data prevents biased models and improves and prediction accuracy. Okay, it will give the perfect results. Now we'll see the handling techniques for handling missing data. There are two major approaches. One is deletion and imputation. Deletion means there are two types: row deletion, column deletion. Row deletion means remove the rows with missing values, works if very few. Okay, if we remove the rows in missing values, it will work in a very few. If the missing values is few, then it will work out. Column deletion means removes columns if too many missing values. So if less values, row deletion, high missing values, column deletion. Okay, imputation means filling missing values: mean imputation, median imputation, mode imputation. Okay, mid imputation means fill with average. Like if we see an example, age is equal to 25, NaN 30, NaN will be replaced with 27.5. Okay, this is the mean imputation. Median imputation means better when data has outliers. Outlier means odd one out. Age is equal to 25, NaN 100, replace NaN with 25. Okay, this is what the median. And mode imputation is best for categorical. Example, city equal to Delhi, NaN Delhi, replace NaN with Delhi. It is the mode. In real projects, imputation is very common. In healthcare, missing blood pressure values can be replaced with the average for the patient's age group. So this is what the techniques for handling missing data. Okay, hope you understand. Next we'll move to the next slide. Handling duplicates in data. Okay, before seeing that, we'll see the handling missing values in age column. In the Titanic dataset has missing values in the age column. So why filling missing values means machine learning models can't handle missing data, right? No one without the further information, no one can do a perfect work. Like this, filling ensures a complete dataset for accurate prediction. If we fill correctly, then it will give accurate predictions, right? Why we are using median instead of mean means mean can be affected by outliers, very old or very young passengers. So this is what the reason. Median is the middle value and more robust for skewed distributions like this. Okay, if we see a Python example here, data age fill na data age median. Okay, so here implies equal to true because it will give the correct predictions. Result is missing ages are replaced with the median age because providing it a more reliable estimate than the mean. So this is what the handling missing data in age column. As we see a diagram here, age, median and frequency. Here we'll observe that median will be the perfect instead of mean. Okay. Now handling duplicates in data. Duplicates occur when the same row is repeated multiple times, right? Rows that appear more than once in a data set and can mislead analysis and reduce model accuracy. So it is very dangerous. They inflate statistics like averages. They mislead ML models by over representing certain cases. Okay. Next example, if we see, imagine a marketing data set when one customer clicked an ad once but their entry appears 5 times. the model wrongly thinks this customer clicked 5 times, biasing results. There we see drop duplicates equal to DF. Duplicates, drop duplicate means it will remove the duplicate values. Okay. After this, every record is unique, ensuring fair and accurate learning for this model. And now we'll see the handling outliers in data. Outliers are extreme values that differs drastically from most data points. They are like a person who is 8 feet tall in a group wherever everyone else is around 5 to 6 feet. As I said, it is a odd one out. Like most Titanic passenger fares $10 to $100, but few passengers paid $500 to $5,000. So this is what the outliers, and why outliers matter means they distort model training, especially for algorithms that rely on average or distance. Okay, it by having the outliers, the model may give less accurate and predictions. It will not give the perfect results. They can skew statistics like mean and standard deviations. This may lead to mislead. Okay, not handled properly. How to detect outliers means there are such ways like box plots, Z-score, IQR method. Box plot means points outside the whiskers are outliers. Okay, and Z-score means statistical method. Values with Z less than 3 or greater than 3 are often outliers. Okay, IQR method means values outside Q1 minus 1.5 into IQR means, or IQR means we'll see that later, or Q3 plus 1.5 into IQR outliers. So IQR method we'll use this less, but here we are using box plot. Means box plots are outside points outside that are outliers. Okay, handling means removing if there are errors. Example, age recorded as 500. Cap values to upper or lower limits. Keep them if they are meaningful. Fraud detections are rare but important. So don't blindly remove outliers. First task. Okay, is this an error or does it hold valuable information? Okay, in this way we can handle the outliers perfectly. Okay, and detecting the outliers. How can we detect the outliers? Outlier can distort analysis and affect ML model performance. So why we want to detect outliers means they'll affect the model performance and not give the best accuracy, and detecting them in first step before handling it will be very helpful. Okay, in graphical representation of data distributions, here values are outside the whiskers are considered potential outliers. Okay, these are the outside the box plot, these are the potential outliers. Quick and initiative way to see extreme values. Okay, IQR means in quartile range. These are the statistical methods we used for in quartile range. Outliers are values outside Q1 equal to 1.5 into IQR or Q3 plus 1.5 into QR. This is what we use the formulas for detecting outliers. And Z-score method measures how far a value is from the mean in terms of standard deviation. Typically values with Z greater than 3 or Z less than 3 are considered as outliers. Okay, this is how we detect the outliers and why detecting outliers is important. Now we will see the handling noisy data. Noisy data is data with random errors or irrelevant variations. Think of measuring your weight on faulty weighting scale. Sometimes it shows 70 kgs, sometimes 71 kgs, sometimes 69 kgs, all within 1 minute. That's the noise. So causes of noise is because human mistakes, sensor errors or environmental disturbances. Like human mistake means in typing or data entry mistakes. Measurement error means temperature sensor fluctuating or faulty sensors. And external disturbances means networking interference. Okay. So what are the techniques to handle noisy data? Moving average, exponential smoothing and Gaussian kernel smoothing. Moving average means smooth out values by replacing each point with the average of its neighbors. Common in stock price predictions. Okay. Exponential smoothing means give more weight to recent values that are used in sales forecasting. Okay. And Gaussian kernel smoothing means give more weight to recent observations. Okay. And real world example. If we use the real world example here, in weather predictions, sensor may record sudden spikes in humidity due to wind. Instead of treating those as real, we smooth them to reveal the actual trend. In financial trading, prices fluctuate every second, right? We can't predict them. Noise reduction helps model find meaningful trends rather than reacting to every spike. So this is what, and this is how we'll handle the noisy data. And we'll see the cleaning of Titanic dataset, why cleaning is needed, and handling missing values and dropping irrelevant column. Cleaning is needed because real world datasets have missing values or irrelevant columns. So these can make the model less accurate and perform badly. And handling missing values means age embarked external disturbances means age means some passengers don't have ages with age recorded, and embarked means some passengers don't have mode or no mean age. External disturbances means with most common mode. Okay. That means environmental issues like interference of network. And dropping irrelevant column means deck contains many missing values not useful for analysis. Result is proper reduced noise. Okay. In this is how we'll reduce the noise in the data set. So we'll see that before cleaning how it will be and after cleaning how it will be there. Okay. It's very good, right? So this is what the cleaning will do. Cleaning is the most important step. And now we'll see the data transformation. As we previously discussed about data cleaning, and in data cleaning we discussed many topics like handling noisy data and handling outliers in data, handling duplicates in data, techniques to handle those, like all this we seen. Now we'll move to data transformation. Data transformation means converting the raw data into structured usable formats. Think of it like translating messy language into clean English so the computer can understand it. So this is what the data transformation. Purpose of it is making the data usable for analysis and ML. Okay, this is what the purpose, and improving the data quality and consistency. As the data is good, and then the data quality and accuracy of model will be good. So now we will see the techniques of data transformation. There are scaling, encoding, aggregation, feature engineering, handling missing values, and data type conversion. Scaling and normalizing means bringing the numbers into fixed range. Okay. At what range it required the value, that range it will fix the values. Encoding means turn text categories into numbers. Aggregation means summarizing the data, like example daily, monthly. So like summarizing the final data. Feature engineering means creating new meaningful features. That means if we give a data set, whatever the needed features are useful for that, then only it will give the new features to the particular dataset. Handling missing values means filling the or removing the incomplete data. Data type conversion means dates into numerical values, like text date to numeric values. Example, e-commerce, raw data sets January 2025. Transformation extracts month equal to 1, year equal to 2025. This is how the data transformation can take place. Data transformation is what makes your dataset truly ML ready. Okay? And encoding categorical data. Machine learning models are math based. They can't directly understand words like red, blue, green. So, right, they need numbers for encoding the process and converting into numbers. There are two common methods for this. One is label encoding, and okay, we see why it needed, because ML models can't work with text directly, and numeric encoding allows models to learn from patterns from categorical features. This is why it is needed. And common techniques is label encoding and one-hot encoding. Label encoding means assigning numbers like red equal to 0, green equal to 1, blue equal to 2. Best for ordinal data where order matters. Example, small equal to 0, medium equal to 1, large equal to 2. And this is the label encoding. One-hot encoding means, as we see that, create separate columns for each category. Example, color column red, green, blue. Red equal to 1, 0, 0. Green equal to 0, 1, 0. Blue equal to 0, 0, 1. Best for nominal data, no natural order. Real world example, in a car dataset, fuel type could be petrol, diesel, electric. One-hot encoding turns into 3 binary columns. Without encoding, models can't distinguish or text properly. They need numbers to compute relationships. So this is what the one-hot encoding. And label encoding means it is a simple but powerful, which means converting the categorical text data into numeric form. It will assign the text data into numeric form, into a numeric number to each category, preserving the order from ordinal data so that machine learning models can process it effectively. Means assigning a unique number to each category. When we'll use this means for ordinal variables where order is meaningful. Example, t-shirt sizes small equal to 0, medium equal to 1, large equal to 2. Okay, each category is assigned a number here, and numbers preserve the order, and ML models can now understand and use this data. Okay, so label encoding is only safe when categories have natural ranking. Now we'll see the one-hot encoding. One-hot encoding solves the problem of false order. One-hot encoding converts the categorical data into binary columns where each category has its own column numbers with values. There we'll see in example table, like everything has its own number, right? Red, blue, green. It will be best to nominal data like categories without any order. Example, colors red equal to red, green, blue. Here how it works means it will create the binary columns for each category. Each row has 1 for the true category and 0 for others. Okay, this is how it works. And benefits of is this: no false ordering, works well with categorical data. And drawback is increases dataset size if categories are many. Example, country column with 200 countries, dataset explodes into 200 new columns. In real world example, Netflix recommendations, genre column like action, drama, comedy. One-hot encoding allows ML models to detect combinations like action plus comedy lovers. So this is what the one-hot encoding. Okay, hope you understand this. And next we'll move for why scaling is needed. In a dataset, features have very less or very different ranges. Example, If we see age ranges from 0 to 100, fair ranges from 0 to 5000. Okay, and machine learning models treat large numbers as more important without scaling. Fair means big numbers here will dominate the model, and age is smaller numbers may be ignored. Scaling, okay, and scaling and normalization brings all features to similar range like 0 to 1, so the model treats them equally, right? So scaling is a very important to prevent bias means errors, and ensure the model learned correctly from all the features regardless from the original range. Okay, so solution is all scaling ensures all features contribute equally. Distance based algorithms like KNN, SVM and gradient descent are especially sensitive. In real world example, if we take in predicting loan defaults, age equal to 35 and salary equal to 50,000. Without scaling, salary dominates. With scaling, both are fairly considered. So this is what scaling is needed. Now we'll see the normalization. Normalization means it is a pre-processing technique that rescales data features into a fixed range. That means it will make the values into a fixed range, usually 0 and 1, so that all features contribute proportionally to the model. Okay, as we previously discussed about this, so with some variation, all values can be in a fixed format. Why it needed means features often have different ranges. Like example, age equal to 18 to 70. Salary is 20,000 to 1 lakh. Algorithms like neural networks are sensitive to scale this, right? Without normalization, features with larger values may dominate the learning process. So it may cause the learning slow and unstable. Okay, for this we'll use this formula like x normalized equal to x minus minimum by x maximum minus x minimum. Okay, x equal to original value here, x minimum and x maximum are minimum and maximum of the feature. Okay, now we'll see the quick example here. If salaries range 20,000 to 1 lakh, one person earn 50,000. Here we normalize 50,000 minus 20,000 by 1 lakh minus 20,000. That means 30,000 by 80,000. So value is 0.375. So salary becomes 0.375 within 0 and 1. Where we'll use this means neural networks because they converge faster with normalized inputs. Image processing, like if we take a pixel values are normalized from 0 to 225, it means 0 to 1. Case study, if we see the case study, handwritten digit recognition like MNIST dataset, scaling pixels to 0 to 1 improves model accuracy drastically. Okay, this is what the normalization means. It is also known as min max scalar. And now we'll see the standardization. Standardization means Z score. Standardization is also a data pre-processing techniques that rescales the feature. That means, so if they have a mean of 0 and a standard deviation of 1, this means the feature on a common scale without distorting differences in the range of values. Simply, standardization rescales values so the mean is 0 and the standard deviation is 1. This is in simple. Why it needed means features may have different scales like height in centimeters versus weight in kgs. So this is, they are having many scales. Distance based models like k nearest, SVM, PCR sensitive to feature scale. Standardization ensures no feature dominates due to its scales. So it will maintain the proper distance calculations. Okay. As we see the formula here, like how it works means x standardized equal to x minus mu by sigma. So x equal to original value, mu means mean of the feature, sigma means standard deviation. So here we'll get the result like data with mean equal to 0 and standard deviation is 1. If we take a quick example here, height of the students mean equal to 170 and SD equal to 10 centimeters, a student with 180 centimeters height. So Z, that means standard deviation equal to 180 minus 170 by 10, that equal to 1. Okay, this is how we'll get the value. So the student is 1 HD standardization Z score above average. Why important means, so ensures no feature dominates due to larger units. In medical datasets, blood pressure 80 to 120 and cholesterol 100 to 300. Without standardization, cholesterol dominates. With Z score, both are balanced. This is what the standardization means. And binning and discretization. Binning means it is a technique that groups continuous numerical values into discrete categories, which means it helps in simplifying data, like reducing the noise and making the patterns easier to detect, which means A is equal to child, adult, senior. So these are the age groups. Binning improves interpretability, reduces the overfitting, and in useful models like decision trees. Okay, if we see a quick example here, suppose we have ages of 10 people. In 10 people, they are the ages 3, 8, 15, 22. So these can be binned, like 0 to 12 childs. So those are 3, 8, and teen is 13 to 19, 15. 15 is the teen, and adult is 20 to 59, and senior is 60 plus. So after binning, the continuous ages are now converted into categories like child, teen, adult. So this is a proper way to analyze the models or for visualization. So this is how the binning is helpful. And if we see the real world example, banking means instead of raw credit scores, grouping customers into low, medium, high risk, it will be very helpful. And binning improves interpretability and can prevent overfitting. So this is what the binning or discretization means. Now handling imbalanced data. Imbalanced data means sometimes in the data sets, one class has many more examples than other. This is called imbalanced data, and it can cause models to ignore the smaller class. So if we take an example here, fraud detection, we have 10,000 transactions, 9,900 are legitimate and 100 are fraud. So a model trained on this data and may predict everything as legitimate and still get 99% accuracy, but it fails to detect fraud, which is what we care about. So this is called handling imbalanced data. Okay, so solutions for this is like how to fix imbalance means oversampling, undersampling, and algorithm level solutions, change evaluation metrics. Oversampling means adding the more samples of minority class, like duplicates or generate synthetic examples. An example, create more fake fraud transactions to balance with legitimate ones. And undersampling means reducing the size of majority class. Okay, example, use 1000 legitimate transactions instead of 9,900. Algorithm level solutions, like use models like decision trees or XGBoost to handle the imbalance better. And changing the evaluation metrics, like use precision, recall, F1. So it will give the better accuracy. So if we see a case study in healthcare predicting rare diseases like 1 in 10,000, if the model always predicts healthy, it looks 99.999% accurate, but it useless. Balancing ensures rare but important cases are not ignored. And Titanic data transformation example. Here encoding categorical features like sex equal to male 0, female means 1, embarked means port or embarkation, C equal to 0, S equal to 1, and q equal to 2. Scale numerical features like fair big numbers. Normalization we use here min-max scalar that scales 0 and 1. Standardization means z-score scales to mean 0 to 0 and standard deviation means 1. All features are here numerical and scaled ready for ML. Okay, here we see that sex is embarked, fair is fair scaled. Passenger 1, 2, 3, sex 0, 1, 2 and embarked is 0.01, 0.50, 0.75. Here in sex 0 is the one error, but also it gives the 99.99% accuracy. So this is how the transformation looks like. Now we'll move to feature engineering. Feature engineering means it is like creating or modifying input data to make it more useful for machine learning models. It helps learn patterns better and improves performance. And for example, instead of using date of birth, we can create age or age group. Proper feature engineering boosts accuracy, reduces complexity, and make predictions more effective. So feature engineering means the art of creating better input features so that machine learning models can learn more effectively. Think of it as a chef using the same ingredients to create a better dish through cutting, mixing and seasoning. So this is what the feature engineering, adding the extra features what it needed. Okay, why it matter means algorithms are more powerful, but they can only learn from the features you provide. Good features equal to better predictions. If we take a example, instead of using date of birth, creating age as we discussed, from address extract zip code to identify location trends. For Titanic survival, combine siblings and parents on board like family size. Okay, and creating better input features for ML as we discussed the examples. And other techniques include scaling, binning, continuous values and encoding the categorical data. Boost model performance. Good feature can improve the model accuracy and make the perfect predictions. Here the impact is proper feature engineering can improve accuracy more than switching to a more complex algorithms. Many Kaggle competition winners rely heavily on feature engineering, not just advanced models. Now types of feature engineering. So feature engineering there are three types: feature extraction, feature construction and feature selection. Feature extraction means this involves creating new features by deriving information from raw data. Raw data means the data which is not pre-processed. It helps the model capture patterns that are not directly visible in original features. So like if we take an example, we'll understand this clearly. From a date column, extract day, month, year or weekday to give the more model insight. So it will give the correct, for model it will understand very correctly. And feature construction means this is about combining or transforming existing features to generate new. So in this feature construction we'll add one more feature to it which is helpful to the real data set. Okay, it can reveal relationship between variables and improve the model predictions, like calculating the BMI equal to weight by height square or total purchase equal to price into quantity. So this is what feature construction. And feature selection means choosing the most relevant features and dropping unhelpful ones. This will be very helpful. Like if we take a customer ID is irrelevant for predicting purchase behavior, remove the redundant variables, reduces noise and speeds up training. If we take the real world example, in finance, raw transaction data can be engineered into spending habits, transaction frequency or loan replacement ratio. These are far more meaningful for credit risk prediction than raw numbers. So these are the types of feature engineering. And now how we will create these new features. So feature engineering, as we see, it is the process of creating or modifying the input data to make it more informative. So it will be helpful for machine learning models. Well engineered features helps more models recognize its patterns correctly and improves its predictions accuracy. So creating new features means combining or transforming existing data into more meaningful variables. Like by adding the both existing data, it gives them more meaningful variable. And if we take a family size equal to SIB SP plus parts, helps the model understand the size of passengers family, which can influence the survival. Feature extraction means deriving features from raw data to make them unusable for model usable for model. Example, extract title like Mr. Miss from passenger names, which can indicate social status or age. So social status means whether the person is married or he is a teen or he is a person who is working. So this will be helpful for model correct prediction. And feature selection, choosing the most relevant features for the model and removing irrelevant ones. As we previously discussed about it, dropping the passenger ID or features with little impact on survival prediction. Okay, this is what the creating new features. And instead of raw transaction data, create average purchase value and purchase frequency. These features tell the model how much more about customer behavior. Why it is important means raw data is rarely perfect. The real power comes from transforming it into meaningful representations. Okay, now dimensionality reduction. Dimensionality reduction means the process of reducing the number of input features. So by removing the unwanted features, it will helps the model to perform better. Okay, and reduce the computation time and prevents the overfitting and improves the overall performance. This is what the dimensionality reduction. So when sometimes data have too many features, hundreds, thousands, they create problems like model becomes slow, risk of overfitting, hard to interpret results. So dimensionality reduction helps the keeping the most important information while reducing the number of features. So here we'll use some techniques for reducing the dimensionality. One is PCA, principal component analysis, transforms the correlated features into fewer uncorrelated components while keeping most of the variance. Okay, let me give you an example. Height and weight are correlated. PCA combines them into a single body size component. This is what PCA. And feature selection means pick only the most relevant features. Example, drop low variant columns like customer ID. Case study, here we see a example. In image recognition, each pixel is a feature. A 100 into 100 image, 10,000 features. PCA reduces this to maybe 10 to 200 without losing much information, making training much faster. Instead of using many individual features like SIB, SP, parts and tickets separately, we can create combined or reduced features such as family side and extract title from names. So here we take the Titanic dataset. As we previously discussed about image recognition, it also helpful. Now dimensionality reduction means simplifying data without losing insights. This is what the dimensionality reduction. And now we'll move to the pre-processing pipeline. Pre-processing pipeline means a step-by-step automated process that prepares the raw data from for machine learning models. It ensures that all pre-processing steps are applied consistently to both the training and test data, reducing errors and saves the time. So typical steps are data cleaning, encoding, scaling, feature engineering. So, pipe and we'll see first why pipelines are important, because it helps to avoid mistakes, ensure the test data is processed exactly like training data, and it saves time and make code reusable. Okay, and now typical pipeline steps: data cleaning, encoding, scaling, feature engineering. As we previously discussed about it, nothing more now. Data cleaning means handling missing values, as we know about it, like duplicate remover, outlier detection. So, and now encoding. Encoding means converting the categories to numeric. Scaling means normalize or standardize, like Z-score or normalization method. Feature engineering means creating or selecting meaningful features and removing the unnecessary features. So, in a case study, if we take a Titanic dataset, fill missing age with median, encode gender like male 0, female 1, scale the fair values like means bigger values, create family size. This pipeline ensures every new dataset goes through the same pre-processing steps automatically. SK-learn pipeline concept and visualization. SK-learn means scikit-learn. It means it is Python's sklearn library that allows you to combine all data preprocessing steps and machine learning models into one sequence. This is what the scikit-learn will do. This makes your work easier because, right, combining all data preprocessing steps will be easier, right, by doing all the steps at a time. This makes your work easier, more organized way, and ensures that every step is applied in the correct order, and it will make us to ensure that every step is correct or not during both training and testing. It will be really helpful. And visualization of the process, as we see, first it will take the raw data. After the raw data collection, it will clean the raw data and encoding, like text data into numerical as for ML to understand it betterly, and scaling them, and feature engineering like removing the unnecessary and adding the extra features which are necessary to it, and model training and prediction. This is how this works. Okay, in Titanic datasets, you can fill missing values, encode categorical columns like sex, scale numerical columns like fair, and create new features like family size. All these steps are combined in a pipeline and applied consistently during both training and testing. So, this is what scikit-learn pipeline. So, it will make us to use very efficiently, and it will be a very fast purpose. And benefits from this is reproducibility. Some same steps applied every time, clean code like fewer errors, more organized, and prevents the data leakage, ensures the pre-processing doesn't peak or test data. With pipeline, you just call dot fit and training data, predict and test data. Okay, and everything runs automatically in the correct order. This is the crucial real world projects where data sets are huge and pre-processing is complex. We'll see the final summary. Let's recap everything. Data processing is an essential step in machine learning that prepares from raw data for building accurate models. It includes, like as we previously discussed about it, cleaning, transformation and feature engineering are combined using a pipeline for consistency and efficiency. Like cleaning means fixing the missing values, duplicates, outliers and noise to improve data quality. Okay, missing values means if in data by human errors or something has occurred, values are missed, we clean the process and then transformation means we use the data into usable format which is learned by the machine. So for this we'll use the encoding, scaling, grouping for better model performance. Feature engineering means create the more important features like family size or extract titles to boost learning. So this is feature engineering. Pipelines means automate the entire pre-processing process. So the best practices are, we have to explore the data first, and we have to know what's missing or what's inconsistent, and avoid the data leakage. Like pre-processing the test data separately from the training, okay, and validate the results, like if pre-processing is actually improving the model's performance or not, okay. Like this we have to check. And pre-processing is not just a technical step, it is the foundation of reliable machine learning. Without it, the best algorithm can't save you. Without it, simple models can perform exceptionally well. And so, final thought is, if machine learning is like a building house, algorithms are architecture, but pre-processing is the foundation. Without a strong foundation, the house collapses. But with clean, well-prepared data, even a simple model can stand tall and strong. And that's why we say good data beats fancy algorithms, always starts with pre-processing. Machine learning isn't just about choosing the right algorithm, it's about preparing the right data. Pre-processing turns raw, messy information into structured, insightful knowledge that models can learn from. Okay, that brings us to the end of my section on data pre-processing and feature engineering. We have seen how clean, structured and meaningful data is the backbone of machine learning process, but this is just one part of the journey. In next session, my teammate will take you to deeper into upcoming concepts that build on what we learned today. And stay tuned because the best is yet to come. And thank you.